What do a toy car, a washing machine, and an electric car all have in common? They are all powered by motors. Motors are incredible devices that transform electrical energy into mechanical energy, bringing our world to life with motion. From the tiniest gadgets to massive industrial machines, motors are essential components that drive countless aspects of our daily lives. Imagine a world without motors. Our cars would remain stationary. Our homes would lack the comfort of appliances like refrigerators and fans, and many industries would come to a standstill. Motors have revolutionized the way we live, work, and interact with the world around us. In this exploration, we'll delve into the fascinating world of motors, uncovering the scientific principles that govern their operation and the diverse applications that make them indispensable. Get ready to be amazed by the power and ingenuity of these mechanical marvels. At the core of every motor lies a fundamental principle of physics, the interaction between electricity and magnetism. This captivating interplay is what enables motors to convert electrical energy into mechanical energy, generating motion. When an electric current flows through a wire, it creates a magnetic field around the wire. This magnetic field is invisible to the naked eye, but its effects are undeniable. When this magnetic field interacts with another magnetic field, it creates a force. This force can be used to push or pull on objects, causing them to move. Motors cleverly exploit this principle by strategically placing wires carrying electric currents within a magnetic field. By carefully controlling the direction of the current flow, the interaction between the magnetic fields can be manipulated to generate rotational force, also known as torque. To understand how a motor functions as a whole, let's take a closer look at its essential components. A typical motor consists of two main parts, a stator and a rotor. The stator is the stationary part of the motor, typically a cylindrical structure that houses permanent magnets or electromagnets. These magnets create the magnetic field within the motor. The rotor, on the other hand, is the rotating part of the motor. It consists of a shaft and a coil of wire called an armature. When an electric current flows through the armature, it creates its own magnetic field. This magnetic field interacts with the magnetic field of the stator, causing the rotor to spin. As the rotor spins, it turns the shaft, which can then be connected to various mechanical devices to produce motion. Section 4. Motors in action, from cars to kitchen appliances. Motors are ubiquitous in our daily lives, powering a vast array of devices and machines. Let's explore some common examples of how motors are used in different settings. Cars. Combustion engines in traditional cars utilize motors, specifically starter motors, to initiate the combustion process. Electric cars, on the other hand, rely heavily on electric motors to power their wheels, providing clean and efficient transportation. Bikes, electric bikes, a popular mode of transportation, incorporate electric motors to assist riders with pedaling, making uphill climbs and long distances more manageable. Household appliances. Motors are the driving force behind numerous household appliances, including refrigerators, washing machines, dryers, vacuum cleaners, and fans. These motors enable these appliances to perform their specific functions, such as cooling, cleaning, and circulating air. Section 5. Different types of motors, a world of variety. While the fundamental principle of electromagnetism remains constant, motors come in various types, each tailored for specific applications. Here are a few notable examples. DC motors, direct current or DC motors, are commonly found in battery-powered devices due to their simple design and ease of control. They operate on a constant current flow and are often used in toys, power tools, and electric vehicles. AC motors, alternating current, or AC motors, prevalent in household appliances and industrial machinery, utilize alternating current, which periodically reverses direction. AC motors are known for their efficiency and power. Stepper motors. Stepper motors offer precise control over rotational movement, making them ideal for applications requiring accurate positioning, such as printers, robotics, and CNC machines. Section 6. Conclusion: the enduring impact of motors. Motors, powered by the captivating interplay of electricity and magnetism, have revolutionized our world, transforming the way we live, work, and interact with our surroundings. From transportation to household appliances and beyond, motors have become indispensable components of countless devices and machines that enhance our daily lives. As technology advances, we can anticipate even more innovative applications of motors, particularly in the realms of robotics, automation, and renewable energy. The future holds exciting possibilities for these mechanical marvels, and their impact on society is sure to continue shaping our world for generations to come.